Now this 2.5 volts voltage source will reverse bias the diode, and the circuit now will look like you have the supply voltage. Now this will be redundant because of the 2.5. Then you have diode which is open circuited, you have load resistance RL, and output voltage VO. You have plus minus VI. Now this is 2.5 and RL. This is open circuited. Since there is no current through RL, your output voltage about 2 volts will be 0. For how much value? Now your VI will go from 2.5 to 3, for VI to 4. So in that case your VO will remain as 0 volts. Again you will decrease from 4 because you are reaching at this point which is 4 volts. Now again you will come to 3 volts. Again your VO will be 0. Again you will come to 2 volts. Now what is the value of VO in the previous case? We have seen for your value of VI to be 2 volts, your VO is 0. So again your VO will be 0 volts, right? Then after that your VI will become 1 volt. So you'll get VO as shown in the previous case. For VI1 you are getting output as minus 1 volt. So you'll get it as minus 1 volt in this case. This is how we are finding the output. Why this is done? In order to get the proper waveform, so that you will not make mistake while drawing the waveform. So all these values have find the value of output voltage, right? Now this is about, again I will come to VI2, 2 volts, 3 volts and so on. So I will get the output in the positive half cycle. Now moving to the negative half cycle. Now what will happen in the negative half cycle? This voltage source is forward biasing the diode, right? Negative, positive, negative, positive. This is already forward biasing the diode, and what we are doing, negative, positive, RL and VO. It is already forward biased by 2 volts, and again we are providing negative part of the supply to the negative terminal of the diode. This is the negative terminal, this is the positive terminal. So again we are applying negative to the negative part. So diode will always remain forward biased in the negative half cycle, and the circuit will be, you have voltage source, the diode will be short circuited, you have RL, you have, now here you will have minus plus, and the circuit will look like this. So when you apply KVL over here, your VO, again equation will be minus VO, or you can say minus plus, it will be minus VI, or you can consider the same direction as in the positive half cycle and take the value as negative. So what you can do for simplicity is consider the same direction, that is plus minus over here. So it will be VI minus 2 minus VO, because the voltage across RL is plus minus VO equals to 0. So again VO is VI minus 2. That is the equation what you have got in the previous case. The same equation what you have got over here we are getting in this case, VI minus 2. Just substitute the value of VI as negative, that is minus 1. When VI is minus 1 you will get minus 3. When VI is minus 2 you will get minus 4. Till how much value we need to go? We need to go till minus 4 volts. So for minus 4 volt you will get it as minus 6 volts. Now how to draw the final waveform? Look here, how to draw the final waveform. During the positive half cycle you are getting the output as minus 2 volts as shown over here. For zero input voltage you are getting minus 2 volts, which can be seen over here. For 0 you are getting it as minus 2 till this point. Then again it will decrease. In the negative half cycle you will get the entire waveform, and the maximum value is minus 6 volts. Now you can see that 0 level is shifted below to minus 2 volts in the clipper circuit because of the DC bias. This DC bias shifts this. You can see the shift because of the DC bias in series with the diode. This is how the bias series clipper works.